We ended up our previous session with you having to do some little work regarding the LOC, ILOC, or lock, ILOC. Pronunciation, it matters a bit, but no understanding what it does, is the most important thing. I trust you're able to come up with a few things. If you weren't, so yes, a quick explanation of what the LOC or the lock and the ILOC are about. The lock and the iLock methods are basically used to reference rows in your data frame. So you recall we had mentioned earlier here, just going to comment this bit out, that you can uh, just get particular column, right? So if you just have your data frame in square brackets and then in single quotes or double quotes, you just have your column name and you have that data set of your column, just that single column returned. If you want it to be a series of columns, you could just, the way we work with lists, right? So you could do this and, oh, sorry, since it's a list, so it has to be embedded as such. So you see we have two columns since we're dealing with multiple columns here. So this is if you're dealing, if you want to make reference to your data frame in terms of column structure. Now, if you want to reference your data frame in terms of the row, okay, so we say smartphone data, which is our data frame here, and now we have the method LOC, okay, now square brackets, IntelliSense is doing its bit. Now the lock method allows you to reference the row by the index of the row. So if you just look at this output here, we're saying this 0, 1. So this is the index number, the position, and you recall when we're working with lists, tuples, and even dictionaries, you can reference things by their positions, in the list, tuple, an array, basically. So that's what the lock allows you. Is based on the lock and the iLock is based on the position of the row. Now, for the lock specifically, it allows you to reference the label of the row. Now, it so happens that for this data frame, the labels are also the positions. Okay, so if we were to say 0, for instance, right, and we close it, you can close this. Yeah, it just gives us the first row. So all the values in the first row. So these all the values in the first row here. And we can just confirm this by coming in here to just run this again. So we see if in the first row is 1 plus 11 5G, you have this value 5499. Okay, if I were to comment this out, remember this rating is 89, and you can see 1 plus 11 5G 5499. That's because we're referencing the very first row based on the position, based on the label, which is also the position. And there I changed it to 1. So it just goes on and on. Now, you could also be a bit more creative with this. Okay. So perhaps you want to do more than just the first row returned. You want to have it like, excuse me now. You also want to include not just the first row, say for from the first row to the third row, and that's what it's saying here. But just to let intelligence know that we're not working with it, so we're going to say make it this. And so what it gives us, it's based on that label, okay, 0 to 3, okay, 0 to 3. I can take this up by 1 notch. So here, yeah, and here is because we're just working with the rules, is returning all the columns. Now, if we wanted a particular column returned, okay, we could also specify particular column returned. We could put it in, as you've seen in square brackets, or if you want to just say model and execute. So we have those rows, right? The labels 0 to 3, and then for this column model, If we wanted it to have for multiple columns, they would have to be in a list. Now for the iLog, the difference is that for the iLog, I'm just going to allow this be here. For the iLog, is that you're not using the labels, but you're actually using the position. You're actually using the position. So to knock this off here, just to knock this off here. Now we're still getting similar result, but here is using the position 0 to 3. Okay, position. So it's 0 to 3. That's what it's using. And if you want to reference a column, it will be the same behavior. And that's not the focus of today's class. In today's class, what we want to look at is cleaning data, right? So we've imported our data. So how we were able to import our data from CSV, right? And that was this here dot read underscore CSV and said it's applicable if you want to, if your data set was in Excel. You could also import data that are also saved as PDF and several other formats. JSON, Panda library allows you to interact with this. Okay, but the key thing is, so now the data set is in here. What do we do? We've seen how to read it. So now we want to clean it. So sometimes you want data that you have could have some inconsistencies in it, and it's part of our responsibility to clean this data. So just quickly comment this bit out. So seeing this and this, we are going to come to this new line, a new line here, and cleaning our data within the Pandas framework. One quick way of identifying or how the Panda library sees data that is not clean is that it either sees it that it's not a number or it's null. Okay, and of course, with other data cleaning techniques, you also want to look out for duplicates and the likes. The Panda library allows you to do that. However, if you just want to do a quick scan to see inconsistent data, so data that where you have empty like null values, where you're expecting numbers, and you can't see them, you can quickly run that. Okay, so with our data frame in here, I'm just going to say dot. We're checking for if it's NA, okay, NA, NA, and go with brackets, the parentheses there. Now, if I should execute this, what is loaded here now, it's from this view, is our data frame, and it's just, you can see a couple of falls, to move along the columns, you're just seeing a couple of falls. There are also some that if we scroll down, we would also see true, you know, but they're just the point I want to make here is that just using this arbitrarily on its own does not give a clear picture, because so what you might want to ask yourself, so what exactly am I looking for here now? What am I looking for here? You want to know which columns are really affected in terms of which columns have um, data or inputs that are not valid or do not even have inputs in there. So to do that is to just work with a helper function or a helper method, okay? And that is some method which IntelliSense was trying to help us with there. So I'm just going to go with that now. And when we run this, so we just have this brief report of the entire data frame. Okay, so just a brief report on the entire data frame, and you can see all the columns, right? You can see all the columns, and you can see the count of values that do not have that have NA, their entries or the content of that column. There are some that are not consistent, or let's just use a broad term to say data that needs to be cleaned, a column that has unclean data. I'm also going to just apply a sort function to this here. So I'm going to allow this to say ascending is false. So I can just see it, because for the ones that have 0, that means they're okay. Those columns are okay, and we don't need to do so much about them. Let's just expand this to show 50 records. So all of this zero down here, it means the content of those columns are okay and we don't need to do anything. So columns of interest, saying column extended underscore up to, fast underscore charging, rating, processor speed, this and that. So here we're also you're also able to get another look, like another view into the data frame that you're dealing with. And if you want to, like we're saying, you could also just view a particular column. Okay, so view a particular column to have an idea what what that column entails. And so if we're using this extended up to, you can see that some have numbers and some don't have entries in there. Okay, now with this, yeah, it's your discretion, of course. If it's a column of interest, would you say for this data frame here that for if we're going to, we can either, now that there are options, so let's also continue with that. Now that you identify that, oh, you have some columns that have inconsistent data, right? Now to clean it, you have options. You could replace the values in there or the values that are not there. So NA, like it's empty, there's nothing in there. So you could replace it with something static, something maybe dynamic, you have to work something about that. Or you could remove that record, which is the row. You could delete the row completely. So if we're to delete, to say we're going to just delete 480 records based on this column. Now, yeah, it's you looking at it, do you feel that this column is material that every record, every row in this column, extended underscore up to, should have a value in it? Is it okay that some entries do not have values? We all shared with you where I imported this data set from Cargo, right? Smartphone data set. So if it's something that you do not think is material, because the column represents particular details of the phenomenon that we're supposed to review. So say we're still using this smartphone, trying to look stuff about phone. Things that I think must be present will be something such as the name of the phone. Okay, I'm also just going to I want to see the name of the columns. Okay, so I also want that bit displayed. The columns returned. So I can see all the columns in here: brand name, model, price. So for me, this me speaking, I think the brand name, which is the name of the phone, the model of the phone is important, and then the price. You should know the phone that you're trying to go for, right? So you should also know the model you're trying to deal with. In terms of model could represent, the version and the attendant price. So if the name of the phone, brand name of the phone is not present, that for me is an invalid. That could be termed an invalid record. So that could be ruled off. Okay. Now this is me interpreting. Of course, there are several other columns here. I'm seeing things such as a column that says number, norm underscore front underscore camera. So that should be for number of front cameras. Okay. Now I think it's optional. Okay, it's optional. I could, I don't mind if if that particular detail is not there. So if I have a record, say a phone that does not state or for number of front cameras, it doesn't have any, so it's just left blank. I don't think it's enough reason to take off that row, that record. Of course, this is subjective, it's what you think, you are the analyst that matters the most. I'm just sharing my thoughts. All right. So having said that, depending on what do you want to do, that's the next thing. So what do you want to do? There are functions, or methods to help you address such issues. So you could delete such columns. So if I say smartphone underscore data and I go dot drop na, okay, dot drop na. Now you can see something about in place. I'm not going to use the in place right now. So the drop na is that it's going to reduce, it's going to remove all records that have what's it called now? All records that have NA in it, values, records where there are no relevant, that Pandas has interpreted that the data there is not clean or it's not valid. Say to say dirty data. If we were to execute this, okay, if we were to execute this and we try to read the data again, and you want to work with this, it would have cleaned up the data. We're not going to have well, the column that we looked at then was I said number of front cameras, right? So if I'm just going to just drag this so I can see rear cameras. So front cameras, right? So if I want to sort by ascending, I don't have anything that has zero in it. Everything here has a value. Okay. Now for in place, what in place does to explain in place is to tell you that if I still reference our smartphone data just as it is, you know, just just give me smartphone data, this data set, it's still clean. So you can see we have fast charging here. It was a number of front cameras. So number of front cameras, just sort by ascending. And let me see this again. So I think I have to just go to this view here, view data. So view data, I'm just going to the smartphone data. So I can come quickly. I just want you to see this number of front cameras. Okay, so number of front cameras. I still have missing data of four, missing data of four here. If I scroll all the way down, okay, so it's not, let me also sort that bit there. So now it's sorted, so 2 is at the top. And I scroll the way down here, just stay with me. Let's do that quickly. We still have missing values. Still have missing values here. We still have missing values. Why we still have missing values is because this bit of code that we executed it was only stored in memory. It does not affect the original data set. So you could pass this to a variable. So you could say this is clean, clean. So we say this is clean. This can be passed. This clean here now, we don't have anything that says for clean. So if I were to output clean, saying clean here, we won't be seeing anything for missing values. We won't be seeing anything for missing values. Similarly, if we were to also say to view the data based on my view here, okay, and I come to that particular column which we're just using to test this number of front cameras. So number of front cameras, and if I were to sort this and I scroll the way down, I'm just going to drag this down quickly. You see that we don't have uh, any we don't have any, what's it called now, any entry that is null or saying missing values. That's just to let you know that when you exercise these functions, it just stores that particular data frame. Is like a new data frame or a subset of the original data frame that is stored in memory. You can pass that to a variable which you can export, later, perhaps for your reports, and other things that you want to do with it. However, if you're certain, it's good to do it this way, but if you're very certain that what you're doing it's right, that's where you have what you saw in IntelliSense in place. So in place and within by default, in place is set to false, okay, in the definition of that method. But when you say in place, you're setting in place to true, you're now telling the the computer that the original data frame should be adjusted to reflect this command. Okay, now that's when you're very sure. So that means you're making a direct change to the original data frame. All right, I'm going to leave that there. Another method you could also use to clean data. If you don't always want to, you don't always want to drop. That's dropping is deleting. Sometimes you want to replace. Okay, so let's just call this edited. So if you want to replace, of a method that you can use to replace is fill. Okay, so fill. So dot FILNA. That's what you can use. So fill. So you have different options. So you could fill. Sometimes you could just fill with zero. Say fill with zero, and you execute. Okay. I also want to also okay. There's no need for this actually. So with this, even if I were to say view data, let me close this bit. If I say view data and I want to see edited, yeah, edited. Now coming to that column, number of front cameras, okay, and we sort, so we can come to the end if we're going to see any missing value. So we come to the end, we don't see any missing value. Instead, there were four. Now we have zeros in here. Okay, so that's the difference between fill and drop. Now, zero is you specifying something. You could pass anything you want. Okay, you could pass anything you want. You could use the keyword. You could just use a word such as missing, and it's still executed. Okay, so if we come in here and refresh this view. Okay, refresh the view. Number of front cameras, and I sort by descending order there. I scroll to the bottom. I'm having one, so that means because that is not a number, I guess it's taking it to the top. Right? Missing, missing, missing. Now that's one way of working with unclean data, messy data. I'm going to come back to this, but before that, let's just look at one last one. So sometimes you have duplicate records, in a data frame, and you want to delete. I'm just going to pass this to a variable unique here, and the method for that is drop duplicate. So drop duplicate, and with this, you execute this. What you would have in this value, this variable unique, are going to be just values without duplicate records in there. So if any row is duplicated, a complete row is duplicated, it would, have that taken off. So now let's revisit these cleaner functions or cleaner methods. Drop any, fill any, drop duplicates. Now drop any, as we've seen it, it's basically as long as it's looking at the entire data frame, and once it sees any record, irrespective of the column, that has no value or what it has interpreted as any, it's going to delete the entire record. Well, given what I had shared earlier, if I have a brand name, I have the model, I have the price, I'm okay. I'm okay. I'm good to go in that regard. Okay, I don't have to delete everything. Whereas things such as rear camera, rear camera, if rear camera is absent, leave it. If brand name is null, yes, delete. I don't think that's a valid data. So you could also specify um, columns. You could also specify columns that you want um, that you want to use as a criteria. Sorry. You could also specify columns that you want to use as a criteria for applying your drop any function. Okay. And so one how do we do that here? So I'm just going to say reclaim, reclaimed, and smartphone drop. Okay, drop any all the time. Go there. Drop any. But here I'm not using we're leaving it as blank all along. But instead of blank here, what I want to use now is subset. Okay, subset. So that subset is a way of specifying the columns that you want to set as criteria. Okay, so if it's a single column, you could just in quotes, just pass it in quotes as it is, brand brand name, if this is what you want. However, if you're setting that it's more than one column, right, more than one column, then you have to just enclose it in a list. Okay, so with this, you could now say, okay, like I was saying, brand name, model, and also price, right? Price. I don't know, IntelliSense seems to be really picking these things up right now. So you could also specify it as this. And so what happens now is it now uses the criteria of checking with these three columns if they are NAs. So this is going to be the criteria by which um, it's going to drop any column. Okay, makes sense to you? I hope it does. I was always waiting for you to hear your voice. Okay. So that's one way of filtering or setting a criteria of applying the drop any. And similarly, this subset is also applicable to duplicate. So you could also do same thing with the duplicate method. All right, with the duplicate method, you could do the same thing with the duplicate method. Now for the fill NA, you could pass a static value such as this, missing, or you could uh, use some kind of parameters, perhaps it's a number, a particular number you want to deal with. But before I get to that, what I also want to share with you is that sometimes the fill any, so we're trying to replace inconsistent or invalid inputs. And as you saw when we use this missing here, it says it passed the value of missing to something of the including that front number of front cameras. And if you just did a quick observation, you would have noticed that that front camera seems to just be having numerical data, integers, okay, numbers. Now this is a text. That in a way is only going to complicate things even further. So sometimes the fill NA, you want to use it to a particular column, not to all columns. Okay, so now you have to specify the column that you want to deal with. Okay, so I'm just going to say, what was that? Number of front cameras, right? Number of front cameras. And for a number of front cameras now, which is that column, we now say equal to what kind of like rewriting the content of that that column, the entries in that column. So here is where I can now say fill NA, and if I say zero, right? If I say zero like this is so we've looked at cleaning data. First is identifying data that needs to be cleaned using the is NA function, right? And well, a quick way of identifying columns that need cleaning is to append the sum function to it. I also appended a sort function to be able to just get it all in one swoop. And then we have different options based on your discretion. You could drop, you could fill to replace, okay, or you could um, drop also remove duplicate from the data set. So that will be it for today's session, and I'll see you in the next session. Thanks. Bye for now.